Welcome to a video tutorial that explains the concept of equivalence per liter as a concentration unit. There is an introductory video tutorial that gives an overview of solution concentrations. It's a good idea to watch that video first. Let's begin. So equivalents are used when we're keeping track of the charge in a solution. So equivalents only apply to ionic compounds, also referred to as salts. Now, equivalents are related to the mole and the molar mass, and then we have to bring in charge. So the number of equivalents is the charge of the ion per mole. And then the grams, that's simply the molar mass. All right, so for example, if we had calcium 2+, right, 1 mole of calcium 2+, because of the positive 2 charge, would equal 2 equivalents. And then we would look to the periodic table and we would see that that would be a mass of 40.08 grams. So for each ion, we can relate the number of moles to the equivalents through the charge, and then we can relate that to the mass of that particular ion. Now, the concentration of electrolytes, ions, in bodily fluids is very low. So we tend to use the smaller milli unit. So let's go through the conversion from moles and equivalents in grams to millimoles, milli equivalents, and milligrams. So if we had 1 mole, that would be the same as saying we had 1,000 millimoles. And that would be the same as saying we have 1,000 milli equivalents, and the same thing as saying we have 1,000 milligrams. So then what we can do is we can just divide each of these by the common factor of 1,000, and so this equality reduces to 1 millimole of a substance equals the number of charges for milli equivalents or milligrams. So let's do an example for aluminum here. So we could say if we have 1 millimole of aluminum, because of the positive 3 charge, that would be 3 milli equivalents. And then if we go to the periodic table, now we would see this instead of grams, we would see this as milligrams, the molar mass of aluminum. And so we can do this for any ion. Alrighty, so here's a table that provides, I think, a good summary of the relationship between equivalents, moles, and grams. So I think I might try to zoom in a little bit right here. Okay, there we go. All right, so here we have the molar mass, for example, of sodium with the +1 charge. 1 equivalent equals 1 mole, right? And 1 mole equals the 22.9 grams. So here we have 1 equivalent then is simply equal to the molar mass. Where things change is when we have, right, with magnesium, there are 2 equivalents per mole. So the mass of magnesium to create a +1 charge is only 12.15 grams. And then we can continue going. We'll do one more example here. Maybe we should try an anion, right? If we had phosphate, the molar mass of phosphate's written here. 1 mole of phosphate is equal to 3 equivalents because of the -3 charge, right? And the molar mass is here, so we would take the molar mass and we would divide by 3. And this gives us the mass that's of phosphate equivalent to that creates one equivalent of charge. So when you think about one equivalent, you think about that's 1 unit of charge. And it can be positive or negative. Alrighty, now let's go to the next page and practice doing some calculations with equivalence. Alrighty, so for me, anytime I see equivalence in there, I'm going to remind myself that, oh, that should be 2 plus, right? So, and I see millis here, so we'll go ahead and work in milli. So remember that 1 millimole of calcium with the +2 charge is going to be 2 milli equivalents. And then we look to the periodic table, and that would be 40.08 milligrams. All right. So anytime we see milli equivalents, we want to look at the ion in question and probably remind ourselves of this relationship. Now let's look more closely at the question itself. Blood plasma typically contains 5 milli equivalents per liter of calcium ions. Calculate how many milligrams of calcium are in 250 milliliters of the blood plasma. All right, so the other piece of information we have is right here, that we have 5 milli equivalents per liter of blood. All right, so this information came from the question, and this top information came from our understanding of equivalence. Now we can solve the problem. All right, we have 250 milliliters of blood, and so let's see here. So we have milliliters and we have liters here. So we've got a unit disconnect. So there's 10 to the 3rd milliliters in a liter. And now we can get from the blood to the calcium. So for every liter of blood, there are 5.0 milli equivalents of calcium 2 plus. And now the question's asking us how many milligrams of calcium 2 plus. So we have milli equivalents, so now we bring in our understanding that for every 2 milli equivalents of calcium, that would correspond to a mass of 40.08 milligrams of calcium. All right, let's check our units. I think we're done. So initially, we started in milliliters of blood, and we had to do a quick unit conversion to get to liters. Once we were in liters of blood, we could use the equivalence of calcium in blood. And so then we ended up with milli equivalents of calcium, and then we use our understanding of calcium and equivalents to go from milli equivalents to milligrams. So now we're left with milligrams of calcium, which is exactly what the question asked for. So our setup is complete. We punch the values into our calculator, and we get a final result of 25.05 milligrams of calcium 2 plus. And then last but not least, we scan, we look at our data. 2 sig figs here, no decimal, infinite sig figs, 2 and 4 sig figs. So we want to report our answer to 2 sig figs. So it would be 25 milligrams of calcium 2 plus. Alrighty, let's try one more practice calculation before you get started on your homework. How many milliequivalents of bicarbonate are present in 75 milliliters of blood serum sample with a concentration of 25 milliequivalents per liter of bicarbonate? Alrighty, so if we have, let's say again, we have milliequivalents, so we'll go 1 millimole. So we have 1 millimole of bicarbonate, and that will equal 1 milliequivalent of charge, because there's only a charge there. And now we need the molar mass. So for the molar mass, there's 1 hydrogen, 1 carbon, and 3 oxygens. So we add up all of the molar masses using the ratios from the formula subscripts. And we see that for sodium bicarbonate, or excuse me, just for bicarbonate, the mass is 61.02 grams per mole. So 61.02, right? So grams per mole or 61.02 milligrams per millimole, all right? Okay, so this is what we bring to the table as students of chemistry. The question lets us know that there's 25 milliequivalents of bicarbonate in every liter of blood. So that comes from the question. And now, right, we want to know how many milliequivalents. That's what we're trying to calculate, the milliequivalents of bicarbonate. And so where do we start? The only thing left, right? We have a 75 milliliter blood sample. Okay, so once again, we have that unit disconnect that our samples in milliliters, but the information in the question's in liter. So we bring in our unit conversion. And now that we're in liters, we can use the equivalent concentration of bicarbonate, 25 milliequivalents. Oh, see, and in this case, we didn't even need this part, but I tend to just do it anyway. So it's good review. Let's double check our units. Milliliters of blood cancel, liters of blood cancel, and we're left with milliequivalents of bicarbonate, which is what the question asked for. So we're ready to perform the calculation. And we find out that we would have 1.875 milliequivalents of bicarbonate in that 75 milliliters of blood. And then last but not least, we look back at our data, and we have 3 sig figs here, infinite, because it's defined, and 2 sig figs. So once again, we're rounding to 2 sig figs. So there are 1.9 milliequivalents of bicarbonate in the 75 milliliter blood sample. Well, this concludes the equivalence tutorial, and now would be a good time to work a few practice problems to reinforce your understanding.